Hello students, welcome to Husky Math. Today we will be doing inverse trigonometric function. So before doing this chapter, we should know what is invertible function. So if there is a function which is 1, 1 and onto, then that type of function is called invertible because we can make the inverse of that function. Okay, so here I have made one function f from x to y, so which is 1, 1 and onto. As you can see, the x1 is taken to y1 and x2 is taken to y2 and x3 is taken to y3 by the function f. So here we can always reverse the function from y to x and it can be written as f inverse. So here f is a function from x to y such that f of x equals to y. Now the inverse of this function will be f inverse from y to x, okay, such that f of inverse of y will be equal to x. So this is the thing, okay. And one thing we should remember, that the function should be 1, 1 and onto. Only that time we can make the inverse of that function. Let me show you the sine function. Let me make a graph of y equals to sine of x, and let me draw with free hand. So here as you can see, actually the sine function or any other trigonometric functions are not invertible because they are not 1, 1. Okay, so why so? Because here as you can see that sine 0 is 0, sine 180 is also 0, and sine 360 is also 0. That means this is not 1, 1 function. That means for different values of x, that is 0 degree, 180 degree, 360 degree, we are getting the same value of y, that is 0 and 0. And similarly, as you can see that the minimum value of sine, that is when the angle is minus 90 degree, the sine function has the value minus 1, and sine 270 and sine is minus 1. Trigonometric functions are not actually an invertible function, but if we restrict their domains from this point, from minus 90 to, let us say, plus 90. Now here, if I restrict their domains from minus 90 to 90, then it can be 1, 1 and onto, because as you can see that for the value of minus 90, the value of sine function is minus 1, and as the value of x increases, the value of y also increases. Okay, and when the value of x is 0, the value of y is also 0. And again, as we approach towards 90, then the value of y also increases, and it increases up to the maximum 1. Okay, if we restrict our domains from minus 90 to 90, then this sine function can be treated as invertible function. Okay, so actually not only from minus 90 to 90, in fact we can make from 90 to 270 also, but we will study from minus 90 to plus 90, and this interval is known as principal value branch. Okay, this will be our domain. Okay, so we are restricting the domain of sine function. Domain I have restricted is from minus 90 degree to plus 90 degree, and my range is from minus 1 to 1. As you can see here, the sine minus 90 is minus 1 and sine 90 is 1. Okay, so this is my domain and this is my range. For which function? For sine function. Now I can make the inverse of sine function. So I can make a new function from minus 1 to 1 to minus 90 degree to 90 degree. So I will write that function as sine inverse of x. So for sine inverse of x, the domain will be minus 1 to 1, and for sine inverse x, the range will be minus 90 to 90. Okay, similarly for other trigonometric functions also, we can, if we restrict their domains, then we can always make it an invertible function, so which will enable us to make their inverses. I have prepared a table for you guys, which you can do the screenshot, or you can just write it down on the formula copy. So here as you can see, since we have discussed for the sine function, so the function here is sine inverse of x, so the domain is minus 1 to 1 and the range is from minus 90 to plus 90. Similarly for cos inverse x, tan inverse x, cosec inverse x, sec inverse x and cot inverse x.